right now, in the world of AI, there's this huge divide opening up. On one side, you've got the massive behemoth models we all use every day. But on the other, there's a new challenger, one inspired by the most complex machine we know, the human brain. This is the story of what could be a revolution in how we think about and build intelligent machines.
So let's just start with a puzzle, a real head-scratcher. How is it possible that a tiny AI model, a fraction of the size of the big guys, can solve complex logic puzzles that completely baffle systems thousands of times larger? That's the core mystery we're going to unpack here today.
Okay, so to really get our heads around this new challenger, we first have to understand the reigning champion, standard AI. And at their very core, these models are just incredible, world-class pattern matchers.
The philosophy behind almost everything you see today is called connectionism. So instead of a programmer sitting down and writing a million if-then rules, you build a network that learns from seeing millions of examples. It's kind of like how you teach a kid what a cat is. Not with a textbook definition, but by showing them thousands of pictures until they just get it. They see the pattern.
So, what's the engine driving all this? It's a process called backpropagation. First, the network takes a guess. Then, it checks how wrong it was. Then, and this is the clever part, it sends that error message backward through the whole network, figuring out which connections messed up. Finally, it tweaks those connections to do better next time. It's almost like a team debrief after every single attempt, giving super precise feedback to get better.
Now, this basic idea led to some incredible specialists. You have things like CNNs, which are the vision experts. They use these little digital filters to spot edges and shapes in photos. And then you have RNNs, the sequence masters. They have a form of memory, which makes them great for understanding things where order matters, like language.
But, and this is a big but, here's the Achilles heel. Even though we call it deep learning, the way these models reason is actually pretty shallow. Because they have a fixed number of layers, a problem gets one shot, one pass-through. The model basically spends the same amount of effort on 2 plus 2 as it does on a complex logic puzzle. It literally can't decide to think longer about a hard problem.
Now, we try to fake this with clever tricks like chain of thought prompting, where we force the AI to write out its steps. But here's the problem. It's incredibly brittle. Think of it like a line of dominoes. If just one domino falls the wrong way, the entire chain of logic just collapses. It's a crutch, not a real solution.
So, if these giant pattern matchers have this fundamental limitation, what's the alternative? Well, it's time to meet our challenger, the hierarchical reasoning model, or HRM, and it takes its inspiration from a completely different place.
Yeah, the creators of HRM looked at the one and only system we know of that has true general intelligence, our own brains. Our brains don't just work on one speed, right? We have those fast gut reactions, and then we have our slow, deliberate, careful thought. HRM is one of the very first AI architectures that tries to actually copy this thinking fast and slow principle.
The best way to think about it is like a company. You've got the high-level module, which is the CEO. It operates slowly, thinks about the big picture, and sets the master plan. Then you have the low-level module, the workers. They operate super fast, crunching the numbers and executing all the detailed calculations.
And this is where the magic really happens. It's all in how they talk to each other. The workers run a whole bunch of fast cycles for every one slow cycle the CEO takes. So they'll try a plan, report back on their progress, and then the CEO can look at the results and refine the whole strategy. This back-and-forth loop gives it real computational depth. It can try a path, realize it's a dead end, and then actually backtrack and change course.
And this gets to the absolute core difference between these two approaches. Standard AIs think out loud with chain of thought. They're mimicking the language of what reasoning looks like. But HRM thinks silently. All that trial and error, all that backtracking, it happens internally. It's not just predicting the next word in a logical-sounding sentence. It's actually performing the computation of reasoning itself.
All right, so we have two fundamentally different ways of building an AI. The massive pattern matcher versus this compact, brain-inspired reasoner. Let's put them head to head. Let's see what happens when the rubber really meets the road. David versus Goliath.
So let's break it down, tail of the tape style. Standard AI, it's all about pattern matching through fixed layers. Its strength is perception, but its weakness is that it's brittle on logic. HRM, it's about iterative reasoning, using these nested loops. Its strength is complex, multi-step thinking, but its weakness, it's much less tested on broad, general knowledge. It's really a trade-off, pattern matching breadth versus true logical depth.
So how do you really test this difference? You give them a task that's basically designed to break a pattern matcher. The test?
a seriously complex 30 by 30 maze. You just can't solve this by recognizing patterns. It demands real exploration, planning, and most importantly, backtracking when you hit a dead end.
The results? I mean, they're just staggering. You ready for this? The best, most advanced large language models out there, 0% accuracy. Nothing. Their shallow architecture just completely falls apart. But the tiny HRM, with its iterative, silent reasoning, it solves the maze nearly 75% of the time. Now, that's not just a small improvement. That's an entirely different class of capability. Okay, but of course, we need a reality check. Let's not get too carried away just yet. There are open questions. Is the magic really from the hierarchy, or just from having an iterative loop? And can it truly generalize to problems it wasn't specifically trained on? But the biggest question of all is about scale. Can this elegant, compact architecture actually handle the messy, vast knowledge of the real world? These questions are what lead us to the most exciting part of this whole story. What does a model like HRM actually mean for the future of AI? Is this the start of something big? Well, for a long time, AI development was ruled by something called the bitter lesson. And the lesson was simple. Forget clever designs, just throw more data and more computing power at the problem. Brute force scale always wins. But HRM directly challenges that. It proves that for certain problems, especially complex reasoning, a smarter architecture can be way more effective than just a bigger one.
And this really points to a super exciting future, something called neurosymbolic AI. It's a hybrid approach that tries to get the best of both worlds, combining the awesome pattern matching abilities of neural networks with the logical, systematic power of classical symbolic AI. And HRM is a huge step in that direction.
And really, if you take one thing away from all of this, let it be this. The next great leap in artificial intelligence might not come from an even bigger dataset or a faster computer. It might come from finding a fundamentally better blueprint for intelligence itself.
Which, brings us right back to where we started. The whole reason these brain-inspired designs are so compelling is because, at the end of the day, the human brain is the only working proof we have that general intelligence is even possible.
HRM took a couple of big ideas from the brain, like hierarchy and different operating speeds, and the results were just incredible. Which leaves us with one final massive question. What other fundamental blueprints for intelligence are still hiding inside our own heads, just waiting to be discovered?